So again, good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So just a reminder, tomorrow, Veterans Day, there's no class, no Zoom meetings, no office hour. I don't think the math lab's open. I think the whole school's closed down. So after today, we'll be back again on Thursday. All right, so today, eventually, we will cover the last part of section 10.2. But before we do, are there any questions from the first part over the quadratic formula?
No, I don't have any.
Okay. Greg, you?
No, I don't have any.
All righty, then we'll jump right into the second part, and we're going to look at some application problems. So let's see here. I'm going to draw a lovely picture. Let's see. And here, and here, and here. All right, this is, let's see, Nordstrom's, and this is Best Buy, and this is Main Street, and this is First Avenue. Okay, and then we've got these crosswalks going here, 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 and here, and then there's also one that's a diagonal crosswalk. Okay, so you've got an intersection, you got Nordstrom's, and then kitty corner across, you got Best Buy, Main Street, First Avenue, and then there's this series of crosswalks, including a diagonal one. Okay, now here's the question. It says, refer to the illustration below, that's this one. Instead of using the Main Street and First Avenue crosswalk, so instead of using, let's go back, instead of using this and then this, to get from Nordstrom's to Best Buy, a shopper uses the diagonal crosswalk, so they use this one, to walk 97 feet directly from one corner to the other, okay? If the length of the Main Street crosswalk, so that's this one, is 7 feet longer than the First Avenue crosswalk, that's that one. So if Main Street is 7 feet longer than the First Avenue, let's call this X, and this would be X plus 7. Are you okay with where I got the X and the X plus 7? Main Street one is, okay. How much walking does the shopper save by using the diagonal crosswalk? So what we've got to do, we've got to figure out this distance plus this distance, and then subtract that distance to get how much distance they save. But what we're going to take from this whole picture is the triangle. Okay, so I'm going to go to the next page. This is 97 feet, this is X feet, and this is X plus 7. Okay, so we've got this right triangle. Okay, now, so we need to figure out what X is. Then we can find out X plus 7, etc., etc. This is a right triangle, so we're going to use the Pythagorean Theorem. Okay, C, the hypotenuse, is always the longest side, so that would be C. A and B are the two other sides called the legs. Since addition is commutative, it doesn't matter which one we call A and which one we call B, as long as C is the hypotenuse. So how about if we call this A and this B? All right, so from that I get the following equation. X squared plus the quantity X plus 7 squared equals 97 squared, okay? Which gives me X squared plus X plus 7 times X plus 7 equals, let's see here, 97 squared is 9,409. Okay, continuing, x squared plus, I'm going to FOIL, x squared plus 7x plus 7x plus 49 equals 9,409. Combining like terms, we get 2x squared plus 14x plus 49 equals 9,409. Putting this in standard form, subtracting 9,409 from both sides, we get 2x squared plus 14x. And let's see, if we take 49 minus 9,409, we get minus 9360, and that equals 0. Now, all of my coefficients are even, so I could reduce this down. So I'll go ahead and divide everybody by 2. X squared plus 7x minus, let's see, 4680 equals 0. And now I'm going to take this equation and solve it using the quadratic formula. I'm going to recopy this on the next page. X squared plus 7x minus 4680 equals 0. But before I go on, did you need to look at this page any longer?
No.
No, I'm good.
All right. So A is 1, B is 7, C is negative 4680. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 7 plus or minus the square root of 49. We've got minus 4 times 1 times minus 4680, which is going to be plus 4 times 1 times 4680 becomes 18,720. Boy, these numbers are big, aren't they? All right. X equals negative 7 plus or minus the square root of, let's see, 18,720 plus 49 is 18,769 over 2. Now, in the problem, it didn't say anything about rounding to the nearest tenth or hundredth, so that usually means things are going to come out nicely. So let's hope they do. So let's see what the square root of 18,769 is. Aha, it's 137. Okay. So x equals negative 7 plus 137 over 2, or x equals negative 7 minus 137 over 2. Well, negative 7 plus 137 is 130. Divided by 2 would be what, 65? Okay. Negative 7 minus 137 would be negative 144 over 2, which is negative 72. So we're getting 65 and negative 72 for values of x. But if we go back to our triangle, in fact, all the way back here, this is a distance. This is a distance. So they can't be negative. Negative 72 is a solution to the equation, but it doesn't fit the actual problem. So x is 65 feet. X plus 7 would be what? 65 plus 7 is 72 feet. So 72 plus 65 is 137 minus 97 is 40 feet. So basically, instead of walking from here to here, they walk here, they save 40 feet of walking. All right. Any part of that you want me to go over again, or you need to see, or are we good to go on?
Yeah, I'm good.
We're good? Okay. Let's take a look at another situation. Here we have, let's see. It says the largest permanent movie screen is in the Panasonic IMAX theater at Darling Harbour, Sydney, Australia. The rectangular screen has an area of 11,349 square feet. Find the dimensions of the screen if it is 20 feet longer than it is wide. So let's see, if this is the width and this is the length, it's 20 feet longer than it is wide. So if the width is X, the length would be X plus 20. All right with that?
Yes.
We're dealing with a rectangle where area equals length times width. So we've got what? I'm going to actually write it length times width equals area because I like to have my variables on the left. So I'm going to have X plus 20 times X equals 11,349. So there is our equation. X times X is X squared. X times 20 is 20X equals 11,349. Subtract 11,349 from both sides, and we get X squared plus 20X minus 11,349 equals 0. I'm going to take that and recopy it on the next page, so I have a whole page to work with to use the quadratic formula. X squared plus 20X minus 11,349 equals 0. And here back to this picture, if there's anything you're still getting there. We good to go on?
I'm good.
Thank you. I'm good.
Okay, so A is 1, B is 20, and C is a whopping negative 11,349. So X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So X equals negative 20 plus or minus the square root of 400 plus, because we got negative times positive times negative. And let's see, we've got 4 times 1 times 11,349. And I'm getting 45,396 all over 2. X equals negative 20 plus or minus the square root of 45,796 all over 2. And let's see, that's X equals negative 20 plus or minus 214 all over 2. The square root of 45,796 is 214. So X equals negative 20 plus 214 over 2, or negative 20 minus 214 over 2. Well, let's see. If we take negative 20 plus 214, we get 194 divided by 2 is 97. If we take negative 20 minus 214, we get negative 234 divided by 2 is negative 117. Now, again, the negative answer is a solution to the equation, but because we're dealing with length, distance, width, whatever, this solution is not valid, okay? We can have equations where negative answers are correct, but when we're dealing with distance or length or time, negative answers don't work. So we've got X is 97. So back here, this is 97 feet, and this would be what, 117 feet? And let's see, did they want anything else? They didn't. Oops, I wrote too many ones there. 117 feet. There you go. Now, the only thing that bothers me about this problem is that I think Australia uses the metric system, So why are we doing it in units of feet? And that probably explains why its dimensions are, or it's, you know, anyway, that's all, whatever. All right, any questions about this problem?
Nope.
Okay, let's take a look at another one. Okay. Parks. Central Park is one of New York's best known landmarks. Rectangular in shape. Okay, so we've got a rectangle. Its length is 5 times its width. Okay, so the length is 5 times the width. We'll call the width x. The length will be 5x. When measured in miles, its perimeter numerically exceeds its area by 4.75. Now, its perimeter numerically. The reason they're saying that is because the perimeter would be in units of miles. The area would be in units of square miles. So it's basically saying, ignore the units, just look at the numbers, okay? When measured in miles, its perimeter exceeds its area by 4.75. So the perimeter is equal to the area plus 4.75, because it says the perimeter exceeds the area. So the perimeter is more than the area. So to make them equal, we've got to add 4.75 to the area, or we could subtract it from the perimeter. Same thing. You okay where I'm getting this from?
Yes.
All right.
Yeah.
Find the dimensions. And it says, find the dimensions of Central Park if we know that its width is less than a mile. So let's write that down here. The width is less than 1 mile. Okay, that's going to come into play later. So the perimeter is what? 2 times the length plus 2 times the width. So the perimeter would be 2 times the length plus 2 times the width, which is 10x plus 2x is 12x. Okay. The area is 5x times x, which is 5x squared. So using this equation, we're going to put that in for P and that in for A. We're going to get 12x equals 5x squared plus 4.75. Okay. Any questions where I came up with this formula?
No.
All right,
No.
recopy that on the next page. 12x equals 5x squared plus 4.75. So I'm going to take this and I'm going to subtract 12x from both sides. And now I'm going to solve it using the quadratic formula, where A is 5, B is negative 12, and C is 4.75. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Continuing to simplify, x equals 12 plus or minus the square root of 144. And let's see, now we've got, let's see here, negative 4 times 5 times 4.75, which comes out to minus 95 all over 10. X is 12 plus or minus the square root of 144 minus 95 is 49 all over 10. Okay, so x equals 12 plus or minus 7 all over 10. x equals 12 plus 7 over 10 or 12 minus 7 over 10. So this would be 19 over 10, which is 1.9. This would be 5 over 10, which is 0.5. Now, we're talking units of miles. We have two positive answers. They're both solutions to the equation, but recall that it said the width was less than 1 mile. So that's why we would throw out the 1.9 miles answer. That's the only reason we would throw it out. So that tells us that x is 0.5 miles. So this is 0.5 miles, and this would be what? 2.5 miles, taking 5 times 0.5. All righty. Let's see here. Let's do another triangle. No, actually, let's do a picture frame. Picture frame. We'll see if we have time for the triangles. Okay. Picture framing. The matting around a picture has a uniform width. How wide is the matting if its area equals the area of the picture, round to the nearest 100th of an inch? And I will go through all this again. Okay, so we've got this picture. Okay. And it happens to be a scene of a sailboat. So I'll put a little sailboat in there and some trees and some water. Okay, lovely, lovely. Now we've got this frame, this matting. So it's like cardboard matting that goes around the picture. Okay. And it says, even though I didn't draw it very well, it says that this frame, this matting around the picture is uniform width. So that means that this distance right here, which we'll call W, is equal to this distance, which we'll call W, is equal to that distance, is equal to that distance. So the matting around the picture is uniform width. Okay. Now, they want us to find that width. What else do they tell us? They tell us that this distance right here is 5 inches. Okay, so the length of the picture, not the frame, but the picture is 5 inches. And this distance right here is 4 inches. So basically the photo or picture, whatever, is 5 inches by 4 inches. Okay. Now, let me read it again. The matting around the picture has a uniform width. How wide is the matting if its area equals the area of the picture? Well, the area of the picture would be 5 inches times, times 4 inches, which would be 20 square inches. So that's the area of the picture. The area of the frame is equal to that. So the total area would be 40 square inches. Okay, so again, they said the matting's area is equal to the area of the picture. We can see that the area of the picture is 5 times 4, 20 inches. So the matting is the same. The total is 40 square inches. Okay, we all right with that?
Yes.
All right, now let's find the area of the entire thing, because that is the area of the entire thing, right? That's the picture plus the matting. But let's find it a different way. Okay, let's see here. This distance is 5 inches. This distance is W, and this distance is W. So the total would be 2W plus 5. So the base of this matted picture is 5 inches plus W, or 2W plus 5. Over here, this is 4 inches, this is W, and this is W. So this whole thing would be 2W plus 4. Any questions on that?
No.
Okay. So the length times the width of the entire thing is equal to the area. So we've got 2w plus 5 times 2w plus 4 equals 40. We're going to FOIL that together. We get 4w squared minus 8w plus 10w plus 20 equals 40. Combining like terms, 4w squared plus 2w plus 20 equals 40. Subtract 40 from both sides. 4w squared plus 2w minus 20 equals 0. But I could reduce that by 2, so I'll divide everybody by 2, and I get 2w squared plus w minus 10 equals 0. Okay? So after all that, I now have my quadratic equation, which I'm going to copy onto the next page. 2w squared plus w minus 10 equals 0. Okay. Now, I don't know if I mentioned this part earlier, but it says round to the nearest hundredth of an inch. That tells me that my numbers aren't going to come out nicely like the last bunch did. All right. So A is 2, B is 1, C is negative 10. W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Oops. W equals negative 1 plus or minus the square root of 1 plus 80. Is that right? I'm surprised because that's a nice number. Number 4. Okay. Hang on a second here. All right, I found a mistake right here. Okay. What should that have been? Should have been plus 2w times 4 should have been plus 8w. You see that?
Yeah.
So now let's go back and fix my error. So that's going to be 18w. I must be having another Monday. So this is going to be plus 9w. Okay. We all right with that so far?
Yes.
Okay.
Yeah.
So this is going to be plus 9w. So this is going to be a 9. In fact, let's do this. Let's just start this whole thing over here. Okay. One little mistake and it all goes astray. So W equals negative B plus or minus. I do want to point this out though. I knew I made a mistake because of the directions, because it said to the nearest, and yet what I was going to get was going to come out nicely. It's a good thing, otherwise I might not have got it. So then B squared minus 4AC all over 2A. W equals negative 9 plus or minus the square root of 81 plus 80 over 4. W equals negative 9 plus or minus the square root of 161. There we go. That's a little better. That's a little worse in terms of it doesn't come out nicely, that is. So we've got negative 9 plus the square root of 161 over 4. -9 minus the square root of 161 over 4. See if I can write that a little nicer. So let's do the top one. Parentheses. -9 plus the square root of 161. Close it up, close up the whole thing, divided by 4. And I come up with approximately 0.922, rounding to the nearest 100, 0.92 inches. The other one, I get negative 5 point, well, it doesn't really matter because again, negative can't work in this problem. So what is that uniform width? 0.92 inches. So almost an inch of that mat all the way around the picture. All righty. And with that, I think I better quit while I'm almost ahead. So I'm going to stop the recording.